Hello, and welcome to Big Data Migration at eBay. My name is Jeff Stitzel, and I am a BI architect at eBay. I manage the MicroStrategy platform, and joining me today is Hani Sawandi, VP Principal Quality Architect at MicroStrategy. If you're like many, working at home this year has meant retooling the way you normally interact with your coworkers. Questions like, do I share my video? And if so, what should I wear? Do I need one of these? Well, no, I don't think so. So how am I going to get everything done? When planning our key initiatives this year, we opted not to make changes. One of our key initiatives was to migrate MicroStrategy to a new system of record technology. I'm going to talk about our business at eBay, our MicroStrategy environment, the challenges faced with migrating from Teradata to Hadoop, and the solutions that we put into place to resolve those problems. As we get into the challenges that we faced, Hani and I will discuss different examples, and then we will open it up to questions. First, a little about eBay. We were founded and made our first sale in 1995. We've come a long way since then. We now service 183 million active buyers worldwide. We have 1.6 billion listings, and the eBay app alone has been downloaded 542 million times. We connect millions of buyers and sellers from around the world, and we empower business by creating economic opportunity for everyone. This is our current MicroStrategy environment. We have 6 iServer nodes asymmetrically clustered. We did this to support project cube level memory requirements. Some projects needed more memory than others. This is what the MicroStrategy environment looks like at eBay. Each week, 4,500 users connect to up to 12 projects. They create 230,000 sessions and run 115,000 reports. We now maintain more than 290 cubes that users connect to analyze their businesses. In-memory cube datasets account for 80% of all jobs run in MicroStrategy. First, ask yourself, where is the bottleneck? Regardless of the data source that you're connecting to, you will be faced with these same bottleneck questions. This is how our cubes break down in size. The majority of cubes are data sets less than 1 gigabyte. Of the 290 plus cubes, 2 are greater than 80 gigabytes. Data fetch times for larger cubes were a problem for us. We began the process of migration using Spark SQL against Hadoop cluster by upgrading from 2019 to 2020, and then started tuning the individual queries. Pumping all of that data through an ODBC driver can be very time-consuming. In tuning, it is important to remember that there is no one-size-fits-all for figuring this out, as we'll see next in our use cases. When testing the MicroStrategy out-of-the-box Spark ODBC driver, we found that the refresh time didn't meet our business partner's goal. The upgrade to 2020 improved the republish time about 20%. For the rest, we looked to our internal team to provide an optimized ODBC driver. At this point, we partnered with MicroStrategy technology to understand the library dependencies. This required a decoupling of MicroStrategy level Kerberos libraries. This is the quick view of the use case cube. It is our starting point. Here, you can see that there were at 9 hours and 20 minutes just to republish the cube. This represents the data fetch when using Teradata TPT. Think of a highway with one large truck delivering to many locations simultaneously. With Hadoop, imagine a small car delivering to one large location. With partitioning and parallel fetch, many small cars are delivering to many locations simultaneously. This is how we configured. Database instance level VLDB settings apply to all reports using the DBI. We set pre-statement for compressed max size, and we use group by in the select statement, and lastly, a table qualifier to use temp intermediate tables. Make sure that you set the project level advanced configuration for max parallel queries. The default is 2, so making a change here at the project level is mandatory. Recommended increments are 8, depending upon your DBA recommendations and the user level workload management. When using partitioning, the options highlighted in green are supported, those in red are not. Since we're not using partitioning and parallel data fetch for all queries, we set 2 cube level settings, parallel query execution and parallel SQL execution. In this case, we're using derived intermediate table type. The partitioning settings are much more straightforward. Select a partitioning attribute based on cardinality. Notice that we generate SQL showing each partition's individual SQL that will run in parallel. We ended up here from the original 9.5 or so hours to just over 2 hours. These tuning measures allowed us to meet our business partners' republished time goal. Although this is but one example, there are many others. Hani has a few examples to share regarding other customers.
Okay, thank you, Jeff. So as Jeff mentioned, here is another customer cases that is not eBay, but let's learn how we can quickly spot what can be improved here. So this is the summary of the OLAP cube execution. As you can see here, it is starting from 9:45 a.m. on the November 14, and it finished at 1:52 p.m. on the same day. So the total time here is 4 hours and a little bit over 4 hours, 4 hours and 6 minutes. Okay, and in this case, at this point, all the value that you see here are good. That's why I marked them with green here. You can ignore the red part here. Even though I mark it with red, you can ignore it. So the reason at this point everything is good because things are executed in series. So the summation of the time and everything are good. As there is a warning that MicroStrategy indicate there is a potential problem with the summary. So you need to understand which part of the information is correct and which part of the information could be misleading when you later make it parallel. So the key point here is that this is a good cube, that this is a good candidate cube that can be improved because it has no partition at this time. It brings around about 10 million records, and the the bottleneck, as Jeff mentioned, is mostly on the data fetching here, the one that is in the middle here. And first, let's take a look when we partitioning. We need to choose an attribute. And in this particular case, we choose to partition based on the month. Okay. And we choose to partition it into 8 partitions, as Jeff showed. And now let's take a look carefully on the cube quick view statistic. The start time and finish time are all still good. They are all green, meaning the data you can trust. It starts at some point at 10:04 in the morning. It finished at 11:19. So the total time in general is around about 1 hour and 14 minutes here. It is already an improvement because we partitioning. Okay. This number though, the one in red, I highlighted in red and I put across here, is the information that you cannot trust, because this is just the summation of each individual query, even though they are executed in parallel. Okay, but let's think carefully a little bit. Previously, it takes about 4 hours here. That's why this is red, because I highlighted in general. It takes about 4 hours. When we bring the data with 8, supposedly this reduced to, assuming the highway or the network is not the bottleneck yet, it's supposed to reduce the time in the query engine to be around about 30 minutes. Okay, so we suspect at this point, that those partition is not a good partition. In other words, they are not equally distributed. The data is not equally distributed. So at this point, we decided, let's choose a different attribute. And we choose a location attribute. And look at the number here. The number of record is still 10 million. They're exactly the same. But the total time now reduced a lot. Okay. It started at 2:57 p.m. and it finished at 3:35. And as you can see here, the total elapsed time in the query engine, which is a measure that you can trust on how long the data fetch is going down to roughly about the right amount. From 2 hours divided by 8, it is going to be roughly about 30 minutes. Of course, you cannot get exactly 30 minutes, but you can see here. That's why I mark it in green. You still cannot trust these two numbers because we simply doing a summation of all the individual passes in this case. Okay, so here we feel that this attribute is a good attribute to do the partitioning, and at the end, the customer doesn't want to bring just 10 million. This is their actual target. They decided they wanted to bring 86 million. This is more than like a few months, actually. We still keep the location attribute because the location attribute is independent of the time dimension, as you can imagine. And they choose to do 16 partition in this case. And you can see the number of data that need to be moved increased by 8 times. And naturally, the time getting back from 30-some minutes to close to 120 over 120 minutes, 2 hours, basically. Okay, so this is the one that another example that illustrate to you how you can quickly spot on your system cube that is big in size, as Jeff mentioned, and you can quickly turn it around to improve it by doing the partition.
Thank you, Hani. At this time, we'd like to open it up to questions. So on the screen before you, you can see our contact information. If you think of something later, please email us and we'll get back to you.